Up until now, we've dealt with the PyWeb API strictly as a request and response type format. What if you want your application to know when the values for a particular tag have changed and automatically respond, rather than requiring a request to identify changed values? The PyWeb API has channels which support WebSockets to do just that. WebSockets function on a different protocol from HTTP requests called WSS, or Secure WebSockets, similar to how HTTPS is secured by SSL certificates. A WebSocket will open up a persistent connection to the PyWeb API service. The channel will remain open to receive any payloads from the PyWeb API service. The channel is registered for particular points or attributes, and when a new or changed data value arrives, the new value will automatically be sent to the channel. We only need to pick up these events ourselves and process them. The JSON messages containing all of the stream value changes will be in the same format as the getEnd endpoint for streams and streamset controllers. Channels have a polling interval which determines how often the PyWeb API sends these updates through the channel. This can be changed by the channel polling interval configuration attribute in the AF configuration database, which sets the number of milliseconds between polls. The default is once every second. If there are any updates in between polls from the PyWeb API, say for example you have a tag which updates every quarter second and a polling interval is 1 second, these events will be sent too. As a result, you can have multiple event updates for a single message in the channel. It's also important to note that in the case of multiple event updates for a single message, the updates are not guaranteed to be in chronological order in the JSON response message being returned by the channel. In order to use channels, we first need to open a WebSocket with the PyWeb API. This initial opening of a WebSocket is an HTTP request, and can support URL parameters such as include initial values to get a value upon opening the WebSocket. The request for the WebSocket to be opened is the base URL /streams /the web ID of the streams, and then channel. For this example, I'll be using a tag I created in an earlier video, as I plan on writing values to it to demonstrate the features of the WebSocket. To demonstrate WebSockets, we're going to need to add a new tool to our toolset, an online WebSocket tester. We're going to open up a WebSocket in the tester, then post new values to the point we've opened the WebSocket for, and see the values have updated in the tester. Let's use websocket.org/echo. For this, I've made a few changes to my security temporarily to expose my PyWeb API service to allow connections from outside my testing domain. In the location, we'll put the URL for the test tag. Note the change from HTTPS to WSS, streams, the web ID of our tag, followed by channel. Let's connect. Now that we can see everything is connected up, let's use Fiddler to send some new values. I have a pre-written post for this tag here. I'll hit execute. We see the 202 result for the post means that the value is accepted. So let's check in our WebSocket to confirm that that value was able to be received by the channel. As you can see, the new values are updating in our testing tool. Let's take a look at this in a little bit more clean format. I'm using this JSON formatter website to make the JSON look a little bit cleaner. We see the web ID, the name of my tag, the path to the tag, as well as the new event that we've added to this stream. Now that we've seen that the WebSocket can receive new values, let's test out deleted values or edited values. Let's open up System Management Tools and edit an event for this tag and save it. Again, we can see that change being reflected in our client, though this time the update is formatted a bit differently. As you can see, the substituted flag is now true. Now, let's delete an event with System Management Tool. Now, this time we can see the value is no data or system digital state. When developing your application, if you elect to use WebSockets, remember to handle all of these multiple types of events in case events were deleted or values were edited or backfilled. In order to take advantage of WebSockets, you'll need to have an observable or similar in your client code that's capable of handling programmatic events when new messages are received in the WebSocket. If you're concerned about the WebSocket channel being broken and your client application not being informed of that network interruption, you can use the heartbeat to confirm the WebSocket is still alive and connected to the PyWeb API. To add a heartbeat to the channel, you'll need to add the heartbeat rate URL parameter on the initial opening of the WebSocket. So let's disconnect this and demonstrate that. We can see that we get a number of null update events now. So, if you're planning on using the heartbeat to confirm that your WebSocket is still alive, remember that you will need to handle null updates. If you ever need to know how many channels you have open, you can always query through the channels/instances endpoint on the PyWeb API. This keeps a running list of channel instances. As we can see, we have one channel currently open, and we've had 39 messages sent to that channel so far. In this video, we introduced channels, a tool that allows you to react to updates for points as they occur. We also discussed how the underlying technology for channels are WebSockets. We demonstrated WebSockets by using WebSocket.org's online test client to post new values. We demonstrated the difference in message format when the values are updated, as well as the difference in message format when values are deleted. And lastly, we introduced some health checks for channels, such as the heartbeat rate URL parameter, which provides null updates in the case when no updates are available for the stream. We also showcased the channels/instances endpoint for keeping track of your currently open channels. We hope you find use in the Channels feature of the PyWeb API.